All of you, welcome to our class. Today we are here again with a new chemistry topic, that is structure of atom. It's a very important topic in your chemistry for CBSE class 9 in term 2 examination. The chapter will come. So basically I'm making the video for the student of class 9. So today what the topics actually we are covering from structure of atom. The first one is pudding model of J.J Thomson. Then second topic is Rutherford model. After that, Bohr's model. And the fourth topic will be electronic configuration. So total 4 topics today we will cover here. Okay. So now I'm coming to the first one, pudding model. Pudding model of scientist J.J Thomson. What is that? Now previously it was the concept that atom is the smallest particle and we cannot divide the atom anymore. And obviously this is invisible. But after that the concept was changed when electron and proton, these two different particles were discovered. So that time the whole concept was changed that atoms cannot be divided into further parts. Okay. So when the concept of electrons and protons came, that time the scientist J.J Thomson gave the first atomic structure. So according to him, the atom looks like a sphere. Okay. Now protons, that means all positive charged particles are in the boundary of the sphere, and negative charged particle like electrons, all electrons are embedded in it. So it looks like a pudding and we say this is a pudding model. Okay, but obviously this concept was wrong. Atom is not looks like a pudding. It is not looks like a sphere, and electrons and protons are not situated in this manner. So this concept was cancelled, and next the scientist Rutherford came. So what the Rutherford did that time, he did a new experiment with alpha particles. So fast moving alpha particles he took, as well as the gold foil. Okay. Now alpha particles were placed on the gold foil. This was the experiment, and some things or some observations he found, and as per the observation he gave the conclusions. So what was the first observation? The first observation was most of the alpha particles are moving through the gold foil particle without any disturbance. So 90% of alpha particles, almost I'm telling, they are moving without any disturbance through the gold foil. Okay. Now second observation, very few alpha particles were deflected with a small angle. Okay. Now third observation, 1 out of 12,000 alpha particles were rebounded. Okay. So now based on these 3 observations, what he concluded, the first conclusion was that most of the spaces inside the atom is empty. That is why around 90% alpha particles are moving without any disturbance. Now second conclusion, Second conclusion was that protons are occupying a very small place inside the atom. That is why very few alpha particles are making a small deflected angle. They are making the deflection with a very small angle. Why? Because protons are occupying a very small place inside atom. And third conclusion was that the size of nucleus is very small compared to the whole size of atom. Okay, so this was the model of Rutherford. So actually it was not wrong. The model was okay, right? But some drawbacks came. Like according to Rutherford, when electrons are revolving around the orbit, that times electrons are radiating some energies. Okay, so due to continuous revolving, the electrons are emitting or radiating some energies, and one time will come when the electron will lose all the energy and it will jump into the nucleus. So this statement already was wrong because we know atoms are stable, and this statement of Rutherford is going against the stability of the atom. So Rutherford was unable to describe the stability of atom. Okay, so it was the drawback, as he was not able to describe the stability of atom. That is why his concept we cannot take as a proper concept, as a proper model. So after that, the scientist Bohr came and he gave the proper structure as well as the proper statement regarding stability of the atom. What he said, according to him, the electrons are revolving around the nucleus in a different energy level, and the energy levels are denoted by K, L, M, N, etc. So what is that? This is nucleus. Okay, around nucleus, these are called orbit or energy level. How he indicated? The first energy level or K, second energy level or L, third energy level M, then fourth N. This is how, etc. The energy levels are increasing. Okay, but the first orbit or the first energy level is named with K, right? And electrons are revolving there with a specific or definite energies. So when electrons are revolving in the energy level, their energies are definite or specific. Energies are not changing. They are not losing or radiating any energy when they are revolving around the orbit. They are having their constant or own energies. Okay? Achha. Now, electrons are present in the orbit with the formula 2n square. Here n means number of orbit or number of energy level. Now if I say n equal to 1, that means this is the first energy level, or I am denoting K. K means n equal to 1. Now L means n equal to 2. Next M, that means n equal to 3. Now we are applying the formula 2n square, and here 1, 2, 3, 4, this is how we are putting their values, and we get the maximum electron holding capacity. How? Let's see. Suppose I want to find out the maximum electron holding capacity in the orbit of K. So here n equal to 1, so 2n square equal to 2 into 1 square, it will be 2. So maximum electron holding capacity in K, this is 2. Now L. So n equal to 2. So 2n square, value 2 into 2 square, 2 into 4, 8. The maximum electron holding capacity, this is 8. So now M, n equal to 3. So 2 into 3 square equal to 2 into 9, 18. So these are the maximum electron holding capacity. So the orbit can hold the electrons maximum in this number or less than that, but not more than. It will be this number, exactly this number, or less than that, but it will not be more than that. Understood? Okay. Now, if you want to check the electronic configuration, that was our fourth topic also, electronic configuration according to Bohr's model. So how we can do this? See, I am writing here any element you can choose, like oxygen, very common, 8. This is called atomic number. Now what is atomic number? Atomic number means the number of protons present inside the nucleus. This is called atomic number. So I am writing here atomic number means number of protons. Number of protons present inside the nucleus. This is called atomic number, and we know that atoms are chargeless or neutral. So number of protons and number of electrons are equal in atom. Please mind it, don't forget, this is very important topic. Number of proton, number of electrons in atom always same, but having the different charges. So proton minus, protons are plus, electrons are minus. So they are having two different charges, but their magnitudes are same. If I have, suppose, 3 protons, so definitely I have 3 electrons also, right? Inside the nucleus, if I have 3 protons, so in the orbit I have 3 electrons. Okay, so these are the relation of electron and proton, and that is why we can say one atom is always chargeless. Acha, now check the electronic configuration of oxygen. Now atomic number is 8. So in the first orbit or in the first energy level, maximum electron 2. Next I am writing 6. Why? Just now I have said कि in the second orbit, third orbit, first orbit, so maximum electron holding capacity is there. So they can hold maximum that number or less than that number, but that will not be more than. So here the number is 8. In the first orbit, definitely 2 electrons will be placed, because at the first orbit or the first energy level will be filled with the electron, then rest of the electron will go to the second orbit. Now the second orbit will be filled totally, then rest of the electrons will go to the third orbit. This is how the different orbits or different energy levels are filled with electrons. Now the first orbit is filled with 2 electrons maximum. Now rest of the electrons, how many? 6, because 2 plus 6 equal to 8. So this is the electronic configuration of oxygen. Now suppose I am writing nitrogen. Nitrogen 7. Okay. So electronic configuration will be 2, 5. In the first orbit, maximum electron, that is 2. And in the second energy level or in the second orbit, the maximum electron should be 8. But here the number is 7. So what the number I will write here? 5. 2 plus 5 equal to 7. Now suppose I am writing fluorine. 9. Then 2, 7. So in the second orbit, maximum electron holding capacity 8. 8, but less than that. Here, less than 8. What is the number? 7, because 2 plus 7 equal to 9. Now, neon, 10, 2, 8. Now see, this is stable, or you can say inactive. Noble gas, helium, neon, argon, xenon, krypton, they all are noble gas. They are inactive. Why? Because in their outermost orbit, they are having 8 electrons filled. So they are stable, they are inactive, and rest of the elements they are not having in their outermost orbit with 8 electrons. See here, outermost orbit 7 electron. This is not stable. Outermost orbit here 5 electrons, not stable. Outermost orbit 6 electrons, so they are not stable. So if you find in the outermost in the outermost orbit 8 electrons are present, so you can say these elements are inactive. These elements are noble gases. Okay? But you have to calculate the number. Which number? Atomic number, very carefully. And one by one, step by step, you will feel the number of electrons. Again, I am telling, when the first orbit will be filled with maximum number of electron, then rest of the electron will go to the next orbit. After that, the second orbit will be filled with the maximum electron, then rest of the electron will move to the third orbit. Okay, so this is how we do our electronic configuration. Okay, so today up to this point I have to conclude. Okay, so Thomson, J.J Thomson model, Rutherford model, Bohr's model, and electronic configuration. These 4 points or 4 topics we have covered from structure of atom. Okay, chalo, bye everyone.